Greetings everyone, my name is Prantodev. I am going to present federated learning in medical science. My team member is Kazi Kamruzaman Rabbi and myself Prantodev. Introduction. Working with medical images has always been a struggle for machine learning practitioners because medical images aren't widely available due to their data privacy concern. This is where federated learning comes in as a solution, because federated learning is a process where the model is shared among the users, and user using their own data trains the model, and afterwards the model is sent back to the central server. Then the central server aggregates all the models and takes average from those models to update itself. That's how federated learning works. In this way, data privacy is also preserved and model is also trained, not to mention the model is exposed to the wide demographic locations. Literature review. The key findings from our literature review is that among other existing federated learning algorithms, Fed average works better on non-IID data. Medical industry has huge potential leveraging the power of federated learning. Where the model is exposed to wider demographic location, the model becomes more generalizable compared to even clinical practitioners. And other findings were partial model architecture can also be shared rather than the full model. This process yields good results as well, and results demonstrate that proposed reinforcement learning model outperforms traditional approaches, achieving superior performance across heterogeneous datasets. Methodology. In our proposed methodology, we used acute inflammation datasets. By using this dataset and leveraging the power of federated learning, we will detect whether a patient has acute inflammation of urinary bladder or acute nephritis. This is a classic binary classification problem, and we have chosen logistic regression model for this particular purpose. Our proposed model architecture is that at first we will initialize the global model, then we will share the same model with the clients. Afterwards, the clients will train the model on their own data, and for this purpose we have split the data set into two. For our experimental purpose, we have used two clients. Then afterwards, receiving the model from the clients, we have aggregated the model. We have updated the hyperparameters, and we took the model average from the parameters. Afterwards, the global model was updated. The next part of our presentation will be presented by my group member Kazi Kamruzaman Rabbi. Thank you.
Assalamu alaikum. Now I'm Kazi Kamruzaman Rabbi will present the rest of the portion. In this presentation, we'll dive into the code portion of our project and focusing on our model implementation and the integration of federated learning part. Now into the code portion. First of all, let's start with data processing. Our data set, acute inflammation, has almost 6 features and 2 of the levels, and the levels are for nephritis detection and for inflammation in urinary bladder. First of all, we downloaded the dataset, and then as most of the datasets, most of the features of the dataset are categorical, in this portion we have converted our dataset into a numerical form. As you can see, the yes no categorical part are converted into a 0-1 numerical part, and then we split our dataset into train and test set using 80% for training and 20% for testing. After conversion, the data looks like this. And for the model implementation, we adapted the logistic regression part using PyTorch. The logistic regression model serves as a baseline of our predictive modeling task. It consists of an input layer, and linear layer, and a sigma activation function to predict binary outcomes. as we're detecting a binary classification, we're doing two kind of classification. One first is for the urinary bladder inflammation classification, and another for nephritis classification. For the training process, we have first on the main server, we have first of all we try to run our model on the for the classification of inflammation of urinary bladder, and we have run our model for 10,000 epochs, and after that we have run our model for and this is the accuracy curve and loss curve of our model for inflammation of urinary bladder, and then we trained our model for the classification of nephritis, and we also ran it for 10,000 epoch, and this is the training loss and training accuracy curve of our nephritis for renal pelvis origin classification. And then we have implemented our federated learning part, where we have installed the SIFT model, and we have use the federated averaging part in here, and we have created 4 servers or 4 hospitals. As we can see, these are the clients. We have used our 4 clients for our federated learning implementation, and here is the algorithm where we have implemented our federated averaging weight, where we have gathered the weights of all the clients and then divided with the number of hospitals, and after that we have implemented or set our updated our model's weight with the averaged weight. And after running the federated learning part, we have seen that the model performed well in all the clients, hospital 0, 1, 2, and 3. And for the hospitals, the first hospital has 0.1142, the second hospital has 0.1082, 0.1058, and 0.1345 for the consecutive ones as a training loss, and all the hospitals has an accuracy of 100% for our predictive model. Now let's go to the experiment and analysis part. Now in the experiment, we have already talked that the model was trained for 10,000 epoch for both the diseases, and upon completion of training, the model exhibits the 100% accuracy on the training set for both urinary bladder inflammation and nephritis of the renal pelvis region. Additionally, the training loss was 0.073 for the bladder inflammation and 0.09 for the nephritis and detection. Given the model was a simple logistic regression, and its exceptional performance raises the concerns about the model's overfitting, and the figure actually explains these things, that the model is actually overfitted on the training of the nephritis and urinary bladder. And the rest is the federated learning implementation, where we have implemented 4 clients, and these are represented as hospitals, and the dataset was partitioned among the hospitals, and after training the model for 1000 epoch, each hospital achieved varying training losses and 100% training accuracy for both urinary bladder inflammation and nephritis detection task. The training losses for urinary bladder inflammation detection were 0.1142, 0.1082, 0.1058, and 0.1345 for the respective clients, while the training loss for nephritis detection was 0.1740, 0.1225, 0.1375, and 0.1675 for each of the hospitals. And the figures illustrates our model training accuracy and training losses. Now, for the limitation of our project, as we have already talked that our model was a logistic regression model, and it was a simple model. So our classification of the models might get overfitted. So in future, we'll try to implement in more sophisticated model for our project, and moreover, the acute inflammation dataset has only 120 patients data. So comparatively with a smaller data set, the model tends to get overfitted, as it has mainly seen most of the data in its training cycle. So basically, in our as this is a mini project, for our further research, I think we can try to get more data from our Bangladeshi hospitals on the same categories, so that we can increase the size of our data set, or actually we can try to collaborate with different hospitals to implement federated learning for inflammation in urinary bladder and nephritis. Moreover, we have only used 4 clients for our algorithm implementation of federated learning or Fed average learning. But in real life, I think it would be great if we can collaborate with more and more hospitals. And I think if we collaborate with 20 or 30 hospitals and try to generalize our algorithm much more, I think this will be a better project. And now we have only implemented our project with 4 clients. And for conclusion, I'd like to say that in this project we have tried to implement a mini project which showcasing the federated learning process using the federated averaging technique. I think previously the privacy of the data has been a concern for us for a long time. When we're sharing our data for training machine learning algorithm, federated learning has now secured the privacy of data and allows us to train our machine learning model without the need to share the data across multiple devices. Now we can share our model in multiple devices and train our model on those devices' data and get a better convergence model. And I think that using federated learning in medical science can be a revolutionary approach for solving our day-to-day life problems regarding patients' diagnosis. And that's it. This is the reference of our project. Thank you very much.